Hello guys, welcome to another video of our LeetCode 60 plus days challenge where we solve LeetCode questions from easy to hard. Today we are looking at problem number 24, which is swap nodes in pairs, right? And it reads, given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in the list nodes. That is, only the nodes themselves may be changed, right? Okay. So we can change the nodes. Okay, and then example input head is equals to 1, 2, 3, and then we swap. So basically we take this one, the two adjacent, we swap them, we have this, and then we take these two adjacent and we swap them, we have that. The idea is to solve this without changing the values, but changing the nodes, which introduces a problem because when we swap when we take this and set the next to this, we need to take this and set the next to this. Okay, and then when we come here, we need to swap this, right? When we come to swap this one, we don't only need to take this one and set it to this, and then this one and set it to whatever follows, but we also need to remember the last one and make sure that we set it to this one. And that's the idea here, right? We're going to tackle these two. So first of all, handle empty handle null, which is null and single node list, right? And we're going to check if list if head is equal to null or head dot next is equal to null. We want to return head. Yeah. So head is equal to null, we basically return the same thing. So, and if it is, we just want to return head, which is, and when we run, I hope I have internet connection. It's going to do that. We can just return head here, just for the sake of testing. And so, when we run it, these two should be solved, at least for the preliminary testing. Yeah, so the two cases are solved. This is what I wanted. So you see that? There we go. All right. Now we can then try to solve for the values, right? Now, what I'm thinking is that we need to iterate this list, but in the sense that we are iterating by the factor of 2, okay? And we need to make a check to make sure that there is always a factor of 2 before we iterate. So if we swap this one and there is just one that's left, we just leave it as it is, right? But if we swap this one and it's 2 and there is 2 left, right? We don't leave, we then skip 2 to swap. But if we swap it and there is nothing left, say it's even, right? Then we end there. So we need to, I don't know, so iterate the list by a factor of 2, making sure that we only move to the next node. We go to the next, make sure that we only move to the next if the exist two adjacent, how am I spelling the adjacent right? Where is it? Okay, it's here, adjacent. Two adjacent nodes, right? So left, not left, but it exists additional two adjacent nodes. Additional two adjacent nodes, and that's what we want to do, right? And let me see, we're going to do, is it an if, or let's go while so we are going to put, for now we're just going to use head. We'll change it later, but we'll assume that we're iterating on head and we'll do like current. Let's do current. List node. Now we'll do head. But we'll also do return. We'll do this node. Result, right, is equal to new you know what, let's just put let's just do that for now. We'll initialize it later, and then we'll do while head dot next. So why it has next is not equal to null, right? Do I want to do that? No, because when we finish whatever operation we do here, we want to, okay, we'll do an iteration here, right? There's a condition that is going to go here. But the idea is that when we finish whatever operation we do here, right, we want to check so we make sure that head is not null, head dot has next is not null. Oh, okay, yeah, it's correct. Which means that down here, for the very first time, it's not going to be null. And when it comes the second time, it's going to check if head dot has next. So pardon me. It's going to check if head dot has next. And I want to iterate only when if I want to go to the next, right? Only when there exists okay, let's just do, so I'm going to check why head dot has next sorry is not equal to null. Yeah, y is not equal to null, and then at the end here I'm going to do head is equal to head dot next. So we're just going to put dot next. I think that's all then. Now if okay, we're going to do not equal to null. Okay, because the idea is that it's going to come the first time, it's going to be here, and then it's going to check, and when iterating, it's going to come. I want to and skip here because whatever we're going to do some, let's put hash logic swap logic, right? We're going to run some swap logic here, and at the end of the day I want to skip to the next one. However, I want to make sure that I only skip to this next one so I skip. I want to make sure that if head dot has next, right? So if it head dot next dot has this next is not equals to null, I want to use it, right? Right? Or else I just want to go to the next one, which is head dot next. That one I've already swapped. So basically I'm checking if it's the last one. So if this is the last one, if this is not the last one, if head dot next, if this is not the last one, sorry, if it exists another one, then we use it, right? So that's just one condition that makes sure that, so this will work, and if there's a, let me say I have an even like this, it's going to run here and then it's going to assign it here, and then this will fail this one because it doesn't have next, and then we can then return the head here, we can return the result, here. So this will pass this logic, this logic. However, if we have an even here, it's going to run, and then when it comes, say it has finished these two, right? At the end, like this first one, there is no has next, right? So it does not have like the next. We want to put head equals to null. I'm swapping. So if it has next, it's going to skip and come here, and then it's going to run the logic, but then it's going to ask here, and you realize that it does not have next. Okay. So if we put null, then we just want to increment head just once, maybe. Yeah, I'm hoping that this, yeah, because so we have three cases where we have like an even here. So first of all, we have a case where it's going to do the first swap and then comes to the third. So when it does it's going to check head does has next. When it does the first swap, it's going to check does it have next. Yes. So when it does the first swap, the first swap logic is going to assign the new head to this next logic. Does it has next? So it's going to ask, does this one have a next? Yes. Does this one have a next? Yes. Then it's going to take this one and assign it to head. So we're going to be left with just this one. And then it's going to ask now that does this head, does it have next? If it has a next, this one does not have next. So it's going to come out of the loop and it's going to return the result, which that's what we want. And then we'll have another situation where it's even, where we, like this one, we have next here. So it's going to check, does it have next? Does it have next? It's true, then it's going to come and it's going to run it's going to do the swap logic between these two, right? And then while preserving this one also. And then when it comes here, it's going to ask, does it have next? Which is no. What do we want to do? Do we want to end it? We'll probably just go to the end here. And so when it comes to the end, this one does not have next, it's going to go out. So yes, I think this works. So this should work for this logic at least. So what is left now is a swap logic, right? So the swap logic is that we want to make sure that we swap the first one, the current, so which is head.next, right? The head and the head.next, we swap them together. And essentially, let me see. So I'm thinking, do we need a temporary where we need to take this? So we need to take the previous and then after the result. Okay, so I'm saying that we are going to manually initialize the first two. Since we're swapping and we don't care about the order or something or any multiplication, we're just swapping. The result will be something like okay, we're going to have a temp. I think a temp. So a temp dot next. So temp is not temp is equal to, because from here we already make sure that there are more than two nodes. So this node is equals to here dot next, right? And then the result will be now this not to be head, and then result will point to head dot next, right? And then now this result now result becomes a head, right? Result dot next will now point to, it has to point to the head. Okay. But again, we need to, it has to point to temp, right? But before this, we need to assign temp the temp of next. because when we take this and put it as 1, we still have this extra. We need to also move this and attach it to temp, because remember we just want to take this, attach it here, and then take this, put it 1, then put it, so that it should become at first it's going to become 2 1 3 4, right? So that's what we need to do. So before we assign result to temp, we want to do temp dot next will be equal to result dot next. Okay, and then we take now result dot next equals to temp. So essentially the first thing we do is assign the head to the temporal variable, assign head to temp variable, right? The second is assign the adjacent bracket, the next node, to the head as result, right? Well, to result as head. Okay. And then, so the first one, we take this one, we put it somewhere else. We take this one and put it in the place of 1. It still carries this. Then we want to cut this one and attach it there. Then we assign the remaining nodes from the head. We cut and assign the remaining nodes from the head, from the new head to the temp, right, which is the second value. Okay, so this becomes 1 2, and then we now assign temp to the next result. Assign temp to the next. Assign temp as the next of the head. I think adjacent. Yeah. So that's the whole thing there. Okay. You have a semicolon, 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 semicolon. So at this stage, result, so first 2 have nodes have already been swapped. Is it double P? I think it should be double P. So we begin at the next node. And to do that, we need to essentially run this very command. Okay, now the head, so are we assigning the head anywhere? So the head is still temp, and temp points. So with the head is temp, right? and temp now points to this one. So currently we always, so now we find the head here. Okay, this is where the head is. The head is at position 2. From when we do this swap, the head becomes position 2. This head here becomes position 2. We then have to head.next. So when we do this swap, okay, because we assign head, this is head, to temp, and then later on, come and assign temp, which basically is head.next. So this one, so we assign temp to result.next, so temp is here, and so the head.next now points to this one. Okay, and so head is in the middle, and so if we do head.next, so we just want to do, head.next is equal to head.next. Head, we want to move one step, move one node up, or move to the next here. And essentially, it's not even as easy as that. We want to check if this one has a next. If it has a next, head.next is not equal to null, then we can continue with the swap. However, if it is equal to null, so it's head.next is not equal to null. If it is equal to null, then we just leave it there. Right? So yeah, we maintain head if so if you have just two here, right, it's going to do this and it's just going to assign this head. So it's going to ask, I am here now, is my next null? So if it's just two, my next is null, so it's just going to leave head as head. So that when it comes here, it's going to check head.next is equal to null and skip all of these, and then it's just going to return result. And remember, our result points to the head. Okay, our result now points to the new head. So if we run this, okay, if we comment out this, you see what I'm talking about. It's going to fail, but I want to show you something. It's going to fail for this case, but we should have, yeah, you see that 2-1, then that's what I wanted, so it fails. Now we need to complete this last two. But our fourth case definitely passed, right? And that's because, and this is not correct either. So anyway, that's what I'm talking about. And so for this case, right, we now have to begin at the next node. So the first two nodes have already been swapped, begin at the next, right? And this is what we do. So begins at the next. Okay, and essentially when we are at the next pair, head now becomes this, and so we now have a new head, which is either it's now this, and it's going to ask, is head.next not equal to null, which is true, and it's going to perform the swap again, which I think is same thing. But not the result, right? We're not touching the result. So head is here. So we're here now, and it does has next. We need to remember this. And okay, this is supposed to be the previous, right? So we'll have a list node. This node is going to be the previous, which is going to be equal to, we're going to define the previous here, which is going to be equal to head. Yeah. Right. And then we're going to define the head. So currently the previous is equals to head, and then when we come here, we want to now take this one and swap with this one. So we want to take, so what will happen is that we'll assign the previous, because we already have head, so this head maintains. We'll assign the previous to head.next, and then take head.next now. So we'll take previous.next, which is this one, the next of that one, to be, so anyway, you see what I'm talking about. It's a bit long. If this added, we would have seen. So the first thing we want to do is, now we have two variables. We have this one, and we can get this one, okay? And the idea is we want to cut out this one, and because we already have this one in its own variable as head, right? We don't need to stress anymore for now. We can simply just cut it out and say previous is equal previous dot next is equal to head dot next. Okay, and remember we still have head, right? Head is still head, but now previous dot next equals to head dot next. So we assign this here, and then we want to take now head.next is still pointing to this. So we have previous.next pointing to this and head.next pointing to this. So we have two things pointing to this, two pointers, right? So we want to take head.next equal to, now the head.next is this one. We're taking this one equal to the head. We want to now switch this one to the head, equals to the head, right? And head, remember, is still this one, right? Does that make sense? Okay. And then this does not longer work well. This particular act does no longer work well. Basically, this works well. I think this check is the correct check that checks well. So then we're going to increment head. If head.next, which now is currently at this position, is equal to null, then we're just going to keep it at head, right? And then it's going to come here and it's going to fall out. Let's run it and see what happens. Okay. What's it saying? Oh, this note. Oh, there we go. Yeah, so we also, while fixing that, I also realized that we have not initialized previous. So if this list continues, previous will just remain there. So we have initialized previous.next, right? To this, right? Previous.next becomes head.next. So we need to initialize head. So previous will become head. So previous will become previous. Okay. So we take this and add here. So this point directly here, right? And there is baggage. There is a remainder that comes there. And then we take head.next. So before this one, what we do is we take this one and add it here. Okay, before that, we want to do so we want to increment previous should be equals to previous dot next. Yes. Okay. And now we can, so this is pointing straight here and this becomes a previous now and it continues. So we can now take the remainder of that previous and put it here, which becomes head dot, so head so this also continues to point to this. So we have, so previous dot next points to the previous dot next points to this, right? And previous becomes now previous, so it becomes here. And we want to put points, so previous dot next points, so the first one takes previous dot next and points to head dot next, right? So points to this, so you have this arrow going here, and then we have previous becomes previous dot next here. We have cut out this one completely. However, we want to now, head is still remaining, we want the previous, we want to put head dot next equals to previous dot next. No, so we want to put head dot next. So we just want to take the previous dot next, which the remainder of these ones, and assign it to head dot next. Remember, I'm not saying assign head dot next, and then now assign the new previous dot head, previous dot next, to be equal to this one, right, which is head. Yeah, I think that's what we want to do. So assign the next of previous node to the next of current of head, current, right? And then make the current make the next, then so make the next of previous node, let's use shorthand, the previous. Make the head the next of previous node, the previous node, right? And then we'll make the head of the previous node, then assign head dot next, because this one is still pointing to this, but we want to now move it and let it point to whatever is left after this one. So assign the next of head to the next of the current previous. And then now we'll just assign previous, assign the next of the previous to the head. Assign the head to the previous, to the next of the, assign the head, sorry. Assign the head to the next of the previous node. Yeah. Which is the current previous node. The current previous node. And you realize that head is always one before the next. So head will always be somewhere here, somewhere there. Right? And then we're going to ask if head.next, though if it gets here, it's going to ask this question, which is no, and it's going to end. However, we have external, it's going to ask this question, which becomes true, and it's going to increment that. Yeah, let's check that out now. Yep. So this worked for this one. Let's see if when we submit, it works. Ooh. Okay. That is not good. That's not good. Why is it missing 3? Why is it missing? Why is it missing 3? Okay, I have no idea here. But so I'm checking. So this first one, it swaps the first one, right? And it gets here, yes. Swap the first one, and we have 4, right? So head.next is 3. And so it's going to assign the previous dot next to, okay, now we have 3, right? And so we assign the previous dot next, so this one's next to, we assign it to 4, right? But it continues all of these, right? And we assign the previous to 4. So previous is still 5. We assign the previous to 4, but head remains 3, right? So head remains 3, and the previous is 4. Is now previous to next, which is 5, and the next is 4. And then we assign the head dot next, which is 3's next. Instead of 4, we assign it to previous dot next, which is 6, right? And then we assign previous dot next to head. Yeah. That's why it works here. But I'm shocked that we are having it omit the 3. I don't know if that's something, I have no idea. Yeah, I'm come short. It's not supposed to be omitting anything. This works, because yeah, you see the first two, it does work, it works here, right? Same thing. And the third one is showing that this assignment here does work, right? Where is it? Third one is showing that this assignment, previous dot next, because the previous, let me see, did we assign the previous? Well, the previous is the head before the previous. So the previous is the head here, which is basically the 5, oh, sorry, the 2. And then previous of the next becomes so head. So the previous points to head, which is this, and head points now to this 4, this 3. And it comes here the first time, it says previous, which is 2, previous next, which is 2, and the next of previous so previous is head, and head is 2 here. Okay. And then now we have head equals to head dot next, which is true. And so head becomes 3. And so it comes here, does head has next? Yes, because it has 4. And then previous dot next, which is this 2, the next of this 2 should be equals to head dot next, and head is 3 and the next is 4, right? So it's going to be 2, 4. But head still maintains, we're not change head. Head is still 3. And then we just move previous, should be previous dot next. Previous is still 2, and then previous dot next now is 4. And then we say head dot next is equals to previous dot next, right? Previous dot next is 4, 4, 6, 2. So the next of 4 is 6, right? Head is I don't know, this maybe it's not assigning this one. Previous dot next is equal to head, because this is what I don't think is assigning, but it worked here. It worked here, not sure why it's not working here. I want to check. Okay. You see, even the case 5 works, which is, I think it's the same as case 2, case 1. 1, 2, 3. 1, 2, 3, 4. And we have, you see, it works up to this point, right? Let's say 4. Let's add 6, right? It still works, right? It still works. Let's add let's add 2. At least this should be where we have the problem. Yeah. So how come it works when how is it that the 3 is getting missing? I think this, so it works here, right? It works here, and then, okay, so I'm guessing it works up to this point where it assigns the 3, but then it checks, does it have, so head is still 3, head is still 3, because previous dot next is head is still 3. Okay, I want to do is I want to print out head, sorry, system dot out dot print head. You have like 2 iterations. STD. STD out. So the first is 3, right? So head is 3 and head is 6, which is interesting. Previous dot next is equal to head. Yeah, I don't get it. I don't get it. I don't. Because this makes sense, right? You see, it's getting it correctly. The head, this is 6 here. I don't know, because it's sorting every other thing correctly. You see, it's sorting the 262 and the 262 and the 262. However, the middle one is not. I don't know why it's not doing that. The algorithm makes sense. It's supposed to head is still supposed to assign head to previous dot next, except the previous dot next now. Let's see. Head. Right. And then we're going to have previous dot next. Let's check the previous, right? Remember, we've done the previous. We're going to try to do that again. Okay. Ooh. How is it? Oh, sorry. I was wondering now. Previous value. I need to check the previous value. Previous is 4. Previous is 2. So previous is 4. and we're setting the next of 4 to be head, right? I want to do previous dot next dot value. Okay. Yeah. Yes. Or am I supposed to use a temp as I used the other time? Because yeah, it is. Maybe I'm supposed to use a temp, right? Because what you see here, assign temp equals to head, and then I use temp to work, and then at the end I assign temp. Maybe when I assign head to a new value, what's head dot next? Okay. Just maybe I'm supposed to use a temp where we assign the head, the temp equals to head, so just use like the temp here, right? And we're going to assign temp equals to head, right? And then wherever we use head now, we just use temp next, and then temp.next, and then we're going to use temp, and then head now becomes this. I think this should work. We're not supposed to initialize two of them. Already did that. Still fails. Okay. It's even worse now. 5 to 4 to 6, 3 to 6. It still doesn't change anything. Does it change anything? Nah, it doesn't change anything. Same issue. Yeah, this does not make sense to me. And once again, I'm exceeding. It's just this debugging stuff. That's really annoying. Previous equals to temp.next. So there's a temporary. So assign temp equals to head, which is in this case is going to be this, right? And then we are going to say the previous dot next. So this one's next should be equals to temp dot next, which is 4, and then previous now should be 4, and then we're going to assign previous, and then we're going to assign temp, which is this. Its next should be false next, which is 6, right? And we're getting the values here. We are literally getting the values, right? We are so getting the values here. Which is 6, and then preview the next, which is now false next should be equal to temp, which temp now points to 3, and then we check head. So head is temp, which is basically this one and where it is. Okay, maybe I want to print at this level. Each time I want to print lists, right, of result at this current swap. After the entire swap, I want to print results, I want to print results. Because we didn't even print that. Yeah. Is it a toString? I don't want to write another function to print this thing. It's going to take long. It's going to be a string. We're going to just go through all, we're going to print that. I don't want to let string. Print result. Okay, so we have um, we have 5, 2. So at this stage we have 4, 3, right? So you see there, it definitely puts the 3. And each time we want to make sure that we get the head, right? Right now, I want to see if we can system.out head, right? So head. So this previous dot next. So we have head is equals to, yeah, just head dot value. Okay. All right. So the head is 3. Right. The first thing first, the head is 3, which is correct. The head is 3 here. And the second time it goes, the head is supposed to be 3 rather than 6. Okay. And that is a problem. That is a problem because, oh yeah, the head is 6. It's supposed to, okay, 6 is supposed to, it's correct. It's 6. The head is 6. And that is correct, right? Oh, okay. Yes. Yeah, okay. The entire thing is correct, but because we are, when we add the head, when we compute this, right? The previous now is no longer the previous. It has to move one step forward. So we are supposed to do, yeah, you were supposed to do this, right? Again, just beneath here. So make previous, the previous of the next. We're supposed to do this just again beneath. Yeah, so that's why we lose that 3. That's why we lose that 3, because it then still considers the previous, and if the thing will, if it continues so long, you realize I will continuously lose values. So I think this should do it. It should do the trick. What's happening here? Yeah. Okay. Let's see if our stuff works. Exactly. Once again, we are doing so well these days, 100% capacity. It's fantastic, okay? Although it took us 1 hour, about 20 minutes of debugging, but this is the whole purpose of this series, right? It's not to edit or record and edit. You will not see my videos. There is no beautiful music. There is no kind of like a tutorial kind of explanation. It's more about observing and seeing how a software engineer approach a problem, and the dirty part about it, right? It's not as elegant as people see. And for those of you who are software engineers, computer geeks, you know what I'm talking about. It's definitely not as straightforward or as elegant as a lot of other content creators and developers make it seem. It's nasty, it's dirty, and you can take 40 minutes or 20 minutes to write a good algorithm, but you take like 1 hour, 2 hours, 3 hours to make it better and find the loopholes within that algorithm. So this is how these things work, and I'm happy that I get to show you this and I get to solve this problem on live. And we also had to just write some extra functions here, which is good. We don't need that, so just going to go ahead and remove that. And the code is well commented, and yeah, so I'm going to run that again to save this. Okay, no, actually it automatically saves. And this is what we're left with. So if we run that again to make sure that it saves, because yeah, exactly. So the time complexity is perfect, it's beautiful, it runs perfectly, and it makes sense. It makes a lot of sense, right? Because we maintain the same values and stuff. Which also we don't need this temp here. Right? I can remove the temp here, I think, to make it more optimized. I can remove this temp, and wherever we just say temp, we just replace with head. Yeah, previous temp. Yeah, yeah, head is supposed to be temp. Temp. Yeah. So let's run that again. Yep. So we don't need the temporal variable here, we just need it up here, and that's it. And the time complexity, again, it's, you see, we're using a lot of, the space complexity, we're using a lot of memory, and we're doing a lot of read and write, so it's going to be low, and yeah. And depending on the requirements, these are the kind of things you can optimize for space, you can optimize for time. In this case, we're always optimizing for time, for more efficient algorithms. So I'm happy that we get to do this, and see you next time. I hope you enjoyed the video. If you do, please like, comment, and subscribe. So comment what you think, comment your own approach. Maybe you solved this before. Comment what you don't understand. I will respond in the comments and try to explain the best as I can, maybe in the comments, and maybe do a video even for you. And follow me on my social media at LinkedIn, Ghana Emmanuel, Instagram, Ghana Emmanuel, Twitter, Ghana Emmanuel, Facebook, Ghana Emmanuel, GitHub, Ghana Emmanuel. So follow me there on those social platforms. I'll leave the link in the comments, in the description below. And you can also always check the descriptions for a lot of information concerning the algorithms. The complexity is there. And thanks for watching one more time. Have a nice day, and see you in the next video. Bye.